Hey everybody, I'm going to do 1.2 challenges 4, 5, 6, and 7. So this is just a continuation of the previous screencast I did for 1.2 problems. So challenge 4 the directions say write an equation to represent the following situations. So challenge 4 situation is the sum of twice a number and half the number is 10. So sum means to add. Sum means to add. So it's telling us that there's the sum of twice a number and half the number. So the sum of twice a number and half the number. So the number is referring to a number. So it's the same number they're talking about, so therefore we will use the same variable to represent both. So we know sum means to add. I can go ahead and put my addition sign. Twice a number. So a lot of times people get this confused with squaring a number, such as, I'm going to come over here, such as 3 squared. 3 squared is 9. And when you square something, that means that you're multiplying it by itself. Now, if you say twice something, such as she paid for the football ticket twice. Well, how many times did she pay for it? 2 times. Multiplication is repeated addition. So twice a number would be the number plus the number. So let's say that the number is 4. Okay? So twice the number would be 2 times 4, which is the same thing as 4 plus 4. So that's just a little side note. The difference between squaring and twice of something, it means multiplication. So twice a number would look like this. So let's say our number is going to be y. Y is the number. Twice the number would be 2 times y. And half the number would be 1/2 of y. And then is your equal sign, 10. Twice the number plus 1/2 the number, or half the number, is 10. Now, some other ways that my students came up with writing this one, here's another way. They used the decimal form of half to show that that is half the number. Then there is another way. So dividing something by 2 is the exact same thing as multiplying it by 1/2. This is multiplication here, and this is division. So they mean the exact same thing. Okay? Challenge 5 challenge 5 is, I'm just going to put my paper under here. 6 times the sum of a number and 15 is negative 42. Now, a lot of students were tempted to write the equation like this. 6 times the sum of a number and 15 is negative 42. Okay? But let's be aware that here this is saying 6 times a number added to 15 is negative 42. So finally we agreed that the correct equation will be written like this. 6 times the sum of a number and 15 is negative 42. And one student put it this way. He says that it's 6 times that sum, so you would have to add 15 and whatever x is before you can multiply that by 6. So I liked that explanation. Okay? Now this didn't say solve, so you just had to write the equations. I didn't cross that out, so you won't think that's right. All right, the next one. During the summer, you worked 30 hours per week at Sonic in Purvis. Your wage was $8.75 per hour. You also mowed lawns for $11 per hour and could work as many hours as you wanted. Your financial goal was to earn $400 per week. So challenge 6 is to write an equation so that you earn $400 per week working both jobs. Okay? So, very first thing that we'll do you remember from my screencast yesterday, is draw a chart. The know, need to know, strategy chart. I'm just going to keep this here so we can see it. Alright, so I have my know column, need to know, strategy. Okay, so the students at this point would say, things that they knew, things that the problem told them. So first thing they saw was that you worked 30 hours per week at Sonic. I'm abbreviating. This is hours, this is per, and this is week. All right, and you made $8.75 per hour at Sonic. Now you also mowed lawns for $11 per hour. $11 per hour mowing. You could work as many hours as you like mowing. So work as many hours as you like mowing. And the last thing is that your financial goal was to earn $400 per week. So we want to earn $400 per week. So that's the goal. $400 per week is the goal. All right, I'll move this now so we can see. Okay, so what do we need to know in order to come up with an equation to show that we will make $400 per week working both jobs? The student said that we need to know how many hours will we work by mowing lawns. Mowing. How many hours will we work mowing? So, most important thing about writing an equation is to define your variable. So, we need to know a variable to represent the unknown. So we can write a little statement here. Let's say, I'll do H. Let H equal number of hours mowing. All right. So our strategy will be to write an equation using 30 hours per week at Sonic, $8.75 per hour at Sonic, $11 per hour mowing. We have our goal, which was $400. I should have put weekly, $400 weekly goal. And we will have our unknown, which is H. H will represent the number of hours mowing, or we can say number of hours needed to mow, however you want to say it. Okay, so we know that we're going to write an equation using these things, okay? And remember that an equation is a sentence. It's just written using letters, numbers, and symbols, okay? So it will say the same thing that the problem is saying. So it's sort of like we're translating the words into an equation. Just like you translate English to Spanish or Spanish to English, it means the same thing, it just looks differently, or looks different, excuse me. So, all right, so let's try to write our equation. Some people see that, well, if I work 30 hours a week at Sonic and I make $8.75 an hour, I think I should know how much money I make a week at Sonic, so I could add that to the money I make mowing, which will equal $400 for the week. So some wrote it like this. This says make $8.75 per hour at Sonic times the number of hours you work at Sonic, added to the money you make mowing times the number of hours you will need to mow. And that will total, which the addition sign comes in there too, total to your goal, which is $400 weekly. So at this point, we need to ask ourselves, does that equation make sense? So I like labeling each part because it helps me to remember we're saying a sentence. We're telling the story by using numbers and symbols, okay? So another way somebody wrote this is they went ahead and calculated how much money they made at Sonic. So somebody told me, well, we also know that you make $262.50 at Sonic, and that's per week. Because if we know the amount of money we make per hour, and we know we will only be working 30 hours a week, then she said I can assume that I know how much money I will make at Sonic. So this particular student wrote hers like this. So she went ahead and put the $262.50 here, and then plus 11 times the number of hours mowing equals the 400. So either way is fine. If you're going to go ahead and put in the amount of money you make at Sonic, then somewhere in the table, like preferably in the no column, you would state that I know this, because 30 hours times 875 is $262.50. All right, so to solve it, I'm gonna come up here. As you know, I write big, so I tend to move around on the paper. Okay, I'm going to start with this one since this shows every part of our situation. So the $8.75 an hour times 30 hours is $262.50. So you would need to subtract that from your goal. So $400 minus $262.50 is $137.50. And since we know that we make $11 per hour mowing, and this is how much money we will make mowing that week, because remember, this is your goal, this is your Sonic, so this has to be mowing, so we're going to divide by 11. That is 12.5. So then I ask my students, are we completely done? And sometimes they'll say, yeah, we're done. We have the answer. H equals 12.5. And so I ask them, if you just see H equals 12.5, does that tell you anything about the problem? Is it specific? Because 12.5 could be calculators or tables or pencils. If we don't have a context with our answer, then we're not fully answering the question. So I've already done challenge 6, and now this is going into challenge 7. So how many hours must you mow? So we could write a statement. You will need to mow 12.5 hours at $11 per hour to meet your financial goal of $400 a week. I feel like I should also have put in there the money you make at Sonic. So we could go back and say, since you make $262.50 at Sonic per week, comma, you will need to mow 12 and a half hours at $11 per hour to meet your financial goal of $400 a week. I could put earning $400 per week. So sometimes you might write your statement and look back over the problem and think to yourself, well, does that statement, is that specific enough to be sort of like a summary for this problem, which, you know, it also includes the answer. So if I'd just written this original statement that I wrote, then that makes it sound like that I only have to mow 12 and a half hours at $11 per hour to make $400 a week. But that's not true, because I'm also working at Sonic and I make $262.50 per week. Okay? Alright, so that was challenge 6 and 7. Now I'm going to go to challenge 8. Alright, the perimeter of the Norwegian flag is 190 inches. What are the dimensions of the flag? So challenge 8 says to write an equation to find the dimensions of the flag and then describe your method and justify your solution. Now, the way that I am speaking out loud and talking about how I'm thinking, that will be my justification and description of how I solve the problem. Okay, so I won't be writing a paragraph after I do this. All right, so I know there isn't that much information that we know, but it never hurts to use our 3-column strategy. So we know that the perimeter is 190 inches. Whenever we see a mathematical concept such as perimeter, for example, in a problem, and we see the word is in a number, you can go ahead and translate that into an equation. This is an equation, P equals 190. This says perimeter is 190 inches. So that actually helps to see that this will actually be part of your equation. All right. We know that, let's see, one of the side lengths is y inches, and the other one is 11/8 y inches. And we're trying to find the dimensions of the flag. So just a quick tidbit on dimensions. So we have one-dimensional objects, two-dimensional, three-dimensional, and there is also a fourth dimension. So one dimension, and I'm going to go off on a little tangent down here. One dimension is length. So a line is one dimension. I'm going to say one-dimensional. Two-dimensional, I should say has. One. Sorry. Okay. One dimension has length, such as that line. Two dimension has length and width, such as the flag we're looking at. It's a rectangle. We have length and width. That one just has length. Three-dimensional has length, width, and can you guess the third? And height. So if I was going to use a shape, I could draw a rectangular prism. That has length, width, and height. So I tell my students like we, like as in a human being, is a three-dimensional object, because we have length, we have width, and we would say depth, like how much volume our body holds. And then the fourth dimension is actually time. We probably won't be working with that this year. So in looking at that about dimensions, we are going to be looking for length and width. Also, another thing we can write, let's say that you're not really sure about what perimeter is. Well, that's something we need to know. What is perimeter? And how do you find it? Because they got the 190 from somewhere. That means they've already found the perimeter. So we need to know what that is and how do you find it. So perimeter is going to be the distance around a shape. So I'll just use the flag as an example. Well, no, I don't want to write on that. Okay, let's say I have this rectangle here. If I start here and I'm traveling the distance around the shape, that is the perimeter. Sort of like a fence in your backyard. That is on the perimeter of your yard. Okay, so distance can only be positive, because when you travel a distance, regardless of if you're backing up or going forward, you're still traveling so many feet, or if you want to talk about miles or inches in this case. So if it is the distance, I guess I should write that, distance around shape. If it's the distance around the shape, what would we have to do to find the perimeter if we had the length and the width? Some people like to view it as, well, I will add up all those sides. So in this case, we have two sides with y length and two sides with 11/8 y length. So we could add all these up. I'm going to come over here. I need to keep on. Okay. I'm running out of room. All right. I'm sorry. Okay. So you could do, people like looking at it this way. So y plus 11/8 y plus 11/8 y equals 190, because we know the perimeter. Now that's one way we can write it. Another way that some people noticed, because at first some students said this. They said, well, y plus 11/8 y equals 190. And then we had some discussion about, well, does this y and this 11/8 y represent every side length? And they were like, no, it doesn't. And so somebody suggested, well, we could multiply each of those by 2. So 2 times y and 2 times 11/8 y to show that there are 2 of each. And then someone pointed out, well, I could also write it like this. So they wrote this. Because when we distribute the 2 times y is 2y. 2 times 11/8 y is 2 times 11/8 y. So there are several ways you could write the equation. I'm going to use this one to show you the distributive property, and we'll go from there. And I'm going to have to move this out of the way. Alright, so we have 2. Let me show that. Alright, 2 times y plus 11/8 y equals 190. Alright, so when I distribute, 2 times y is 2y. 2 times 11/8 y will be 22/8 y. And that equals 190. Now we need to combine those like terms. So 2 plus 22/8. Got 4 3/4. So in our calculators, we're not using mixed numbers. So we're going to change this to an improper fraction. 4 times 4 is 16. Plus 3 is 19, so that's 19/4. You keep the same denominator. So we have 19/4 y equals 190. And in order to isolate the y, we have to multiply by the reciprocal of 19/4, which is 4/19. So the reason why you multiply the reciprocal, there's another name for this. It's called the multiplicative inverse, because whenever you multiply straight across the top, I'll do it right here, straight across the top and straight across the bottom, let's see, 4 times 19. So that'd be 76 divided by 76, which is 1. And that's what we want. We want this to divide to 1 so we can bring down the y. And then 190 times 4 is 760 divided by 19 is 40. Alright, so my question is, are we completely done? Have we answered the question? Well, it told us what to do. The directions said, write an equation, which we did, to find the dimensions of the flag. Now remember, the flag is 2-dimensional, so therefore we have length and width. So does this take care of that? And hopefully you'll go back to your picture and see, well, y is 40. So if this is y, then it's 40. And if this is 11/8 y, it will be 11/8 times 40. 11 times 40 divided by 8, it will be 55. And this is in inches. So we have found the length and the width of the Norwegian flag. All right, thank you, and I'll talk to you next time.